This video is probably going to be one of the most value-packed videos I've ever made on my channel. It took me more than 2 months of making, but I'm sure it's really worth it. So in today's video, I want to share with you must-know React Query patterns. So I've been using React Query for a while right now, and I've been using it personally and with multiple clients with different applications. And one thing that I've kept noticing is that there are a few patterns that just keep repeating. And the cool thing about knowing these patterns is that once you have them in your tool belt, it just gets easier to write code using React Query. It just gets rid of a lot of complexity, a lot of small bugs here and there. And the most important part is that, of course, it makes it faster to add new features to your application. So I want to show you these patterns one by one. And in order to do that, I have created an example application illustrating each pattern on its own. So it's going to be the same application, but just change a little bit just to show how this pattern works in isolation. I'm going to put the link to everything in the description, including the app and the code and everything, so you can check it out after watching the video. We're going to start with the simplest pattern ever, which is creating a simple query, and then we're going to build on top of that. We have a contacts table component where we want to get the contacts data from the backend and show it to the user. So for that, we're going to import useQuery, which is a custom hook from React Query. And here we can pass our query function. Here I already have a generated client that has an async function, get contacts, so we don't have to worry about that. Next thing we need to pass into the function is going to be a query key. This is a crucial parameter that we're working with here because the query key is used internally by React Query to identify this query. One of the core features of React Query and a lot of the good parts of React Query come from the part that it has caching built in, and this is going to be used as a cache key, but we're going to see that in the next patterns. So useQuery returns an object with a lot of very useful fields. The first one is data, and this is where our data is going to be. Is pending is going to be true or false, so it's going to be true while it's loading. Is error is going to be true if there is an error while loading the data from the backend. And refetch is just a function that we can call if we want to refetch the query. So then we can use these fields to show a loading state if it's pending. We can show an alert if there is an error, and here we're going to pass in this refetch function so that the user can click on retry, and then we can retry to reload the query. And of course, in the good case, we're going to show a table. So this is the anatomy of a simple query, but I think it starts getting really interesting when we're working with custom queries. So let's go ahead and try to extract that query from the component, and let's create a new file, query.ts. And here we can paste the code that we had before, and we're going to wrap this inside a use contact. So we have a simple function, use contacts, that just calls use query. And now in our component, we can replace this part with a simple use contacts call. Now, once we start introducing custom queries, you're going to see that the code just becomes very readable. We just have our custom query hook call over here, and then we have a pending state, error state, and rendering the UI. Now, one very common use case that you're going to have when working with React Query is that you would want to transform the data you receive from the backend. And for this, we can use selectors. So if you go back to our query here, we can also pass another parameter, and this is going to be select. So here we just get the data, and then we can transform it however we like. So if we have a list of contacts, we can, for example, grab the contacts count and then show it, for example, in the top bar for the user. Using a selector is actually not just a nice to have, but it has a huge benefit when it comes to performance. So returning to our example, let's say that the contact data changed. For example, one of the contacts' name has changed. If we are selecting for the contacts count, then this is not going to cause a re-rendering in React. And as we're working with enterprise scale React applications, re-rendering becomes a huge topic. So this takes care of all of that for you. Now, since we want to use this use contacts hook in different places in our UI, of course, we want to be able to provide our custom selectors, so we can pass it here as a parameter. Now, passing this function as a parameter would actually work, but there are two problems that we have introduced here. Well, first of all, if you want to add other options to the use query hook, then you would always have to add them here as a parameter. So the second challenge here is that you have to define the type of select yourself, which can be, to be honest, a bit tricky. And if you go down this road, you just have to define the types again at every step, and you don't want to do that. A better approach here would be to create our query a little bit differently, and that would be by changing this from a function to a simple object. So we're going to use query options, which is a function that comes from React Query. And this doesn't do anything magical. It just makes sure that the object that we're passing here is matching use query options. So we're just creating a query options. And in our component, we can replace this use contacts with use query, and then we pass in these functions. So we just created an object. Instead of calling use query there, we're calling it here at the component level. And the advantage of this is that we can pass other options to use query. For example, in our top bar, we can spread these options, and then we can pass our own selector, and here we're going to select the length of the contact that we received. And then we can use that to render the UI. Now, up until now, we've been working with selectors and custom queries, and it was all good because we were not using any parameters. But what happens when our query function actually needs a parameter? Well, then we can create parameterized queries for that. Now, if we go back to our get contacts query option, let's say we want to create a second query, and this one would be to get a specific contact by ID. The code for that would look very similar. We're just changing the query key because we work with a different query, and then we're passing in our parameter. And in order to make this parameterized, we're going to turn this again into a function, and this function is going to take the contact ID as a string and just pass it to the query function. And one crucial thing here to do would be to pass this contact ID to the query key. And there is a good reason for that. If you don't pass here the contact ID, there's a high chance that once you're going to load a second contact, React Query is going to look in its cache and it's going to see that it already has a query contacts 1, and it's going to give you the wrong contact from the cache. So a good rule of thumb would be to always pass all the parameters inside the query key. So now we can go ahead and use this inside our component. Let's say we have a contact page and we're getting the contact ID from the URL. We can then pass this contact ID to the query, and then just like we did before, we can render the UI. Next on the list, we have a pattern that you see in almost every website nowadays, and that is pagination. Pagination just allows the user to see a list of results and also paginate between them. So page 1, 2, and 3, and you have a specific amount of entries inside every page. So we're going to implement pagination as a parameterized query. Just like we did before, we're going to start by adding the parameters that we want to pass to our function. In this case, it's going to be the page number and the elements count, and we're going to pass these to the query key and also the query function. And inside our component, we can go ahead and create a state for the page, and we're going to use this state to query the correct page from the backend. And every time that the user clicks on next page, for example, then we can have a function that just updates this state. And the cool thing here is that React Query is going to react to the state change and is going to reload the data for you. So we got all the basic React Query patterns down. Now we're going to move to the really cool ones. And the first one would be prefetching. Prefetching is when you load data in the background so that the user doesn't see any loading state. So in our contacts table example, what we can do would be to prefetch the next page because the user will probably move to the next page at some time anyway. And in order to do that, we can use the query client directly. So we can have a use effect here. And inside our use effect, we're going to check for every page change. And every time that the page changes, we're going to prefetch the query simply by calling query client.prefetch query. And here we can pass our query options. And as you can see, using the query options as an object comes in very handy. Here we also pass in page +1, so we're prefetching the next page. If you want to prefetch the next 3 pages, then you can just call this multiple times with different parameters. Next on the list, we have infinite queries, which is used to create this infinite scrolling effect that you have in social media applications. So any kind of scrolling to load more or clicking a button, load more, and then you see even more results. That's what's handled here inside infinite queries. When it comes to infinite queries, it's crucial to understand how the fetching function looks like. So for that, I have defined the type of getContacts, and this is going to be a function that takes in a parameter, and this is cursor, and it's going to be either a string or undefined. And the function is going to return the contacts, result, and also next cursor. And this next cursor string is what we're going to use to make the next request. So if you think about it, the first time that you make the call, you're not going to pass in any cursor. In the second request, you're going to pass in the cursor that you received in the previous one, and so forth. So when it comes to defining an infinite query, let's get started with the same code that we had before. We're going to get rid of these function parameters and also remove them from the query key. Inside our query function here, we're going to grab the page parameter that is going to be coming from React Query and then pass this to our function. And this page parameter, we need to also, of course, define how it's going to look like on the first page. And here we're going to pass cursor is going to be undefined. And we also need to define how we grab this page parameter from a result. And this is done using this getNextPage parameter. And the cool thing about this is that you don't have to manage these cursor states in a list or something like that yourself. React Query does it internally for you. If we go back to our component, we can change this from use query to another use infinite query hook, and this is going to return the same result as before, but we also have access to some other fields. For example, is fetching next page and fetch next page, and you can use these, for example, inside your code if you have a load more button. Now, as we keep taking advantage of the built-in TanStack query features, you're going to notice that query keys play a crucial role in that. And up until now, we've been defining the query keys inline, but there's actually a better way to handle that, and that would be using query key factories. So our queries currently look like this. We have our query keys that are defined inline, but if you want to access these query keys in other places, which we're going to do in the coming patterns, then it can be error prone to try to recreate them just by hand. So we can fix this by introducing a query key factory, and this is going to have basically the same name as before. And for these query keys, we can just have a simple object with a method called all, and this is going to be the base key for all the queries that are coming. And then we can define a getContacts function to define the key of getContacts, and this is going to start with query key.all, and then we can add the list item to it, and of course all the parameters. And the same thing goes for defining a query key for getContact. Up until now, we only talked about queries, which are used to get data from the backend, but of course, reading data from the backend is only half of the equation. Changing data on the backend is the other half, and we can do that using mutations. So for mutations, we can take advantage of the use mutation hook that comes from TanStack Query, and here we can pass in the mutation function. Now that we defined use delete contact, we can use it inside a component. This is going to give us a mutate function and is pending. And we can use this, for example, inside a button. So when it's clicked, we call mutate and then we pass in the parameters. And if it's loading, we also show it to the user. And one of the coolest features of mutations is that there are also some callbacks that you can pass in. For example, we can have a callback to be called on success. And here we can show a notification contact has been deleted. Or on error, we can show that there was an error deleting a contact. So when you make a mutation, you're going to be changing data on the backend, which means that one of the queries that you have is going to be invalid. So what we need to do would be to invalidate that query and force React Query to refresh the query again. So in our custom mutation, we can grab query client using use query client, and then we can pass in a third callback called unsettled, and here we can invalidate all the queries. So here we're again using this query keys factory that we created before. And by the way, unsettled is going to be called when the mutation is done, and it doesn't matter if it has been successful or if there was an error, it's going to be called anyway. And just like that, we have invalidated all the queries, which means that the next time that we're using any query, it's going to be refetched from the backend. Now, since mutations change data on the backend and therefore invalidate some queries, it does make sense to make this process of invalidating queries easier. And for that, we can use automatic query invalidation. So this is how our mutation looks like right now. I removed the outer callbacks just to make it easier to read. So I have this unsettled function, and here we're invalidating the query using the query client. Now there are two problems with this code. The first one is that as you keep creating more and more mutations, you're going to see that there's a lot of repetition. You always have to grab this query client and then call it inside unsettled. And the second thing is that because we are using this use query client hook, we have to create a function over here with these brackets and also have a return statement. And it just takes a lot of lines of code. But luckily we can improve this by simply passing in a meta object, and here we can pass in invalidates query and pass the query key that you want to invalidate. Then we can also get rid of this query client. And now that we're only calling use mutation, we can also simplify this a little bit more. And as you can see, this reads way easier. We just have use mutation call, the mutation function, and the queries that is invalidating. Now adding invalidates query is not going to do anything on its own. This is a custom field, so we need to handle this invalidation ourselves, and we can do that globally. So let's just jump to your main.tsx file, and this is where we're defining our query client. And inside of it, we can have a global unsettled parameter. And here we can check if a mutation has an invalidates query inside of it. And if that's the case, we can invalidate the queries. I actually made a detailed video about this topic. You can check it out if you're interested. Now, another thing you want to do with mutations, especially when we're dealing with larger scale React applications, is to handle the errors globally. And we can also do that when we're creating our query client. We can have another field on error, and here we can have our custom logic. A very common use case here is to check if there's a 401 response from the backend, which means that the user token is not valid anymore. We can log out the user directly and redirect them to a login page. So it doesn't matter which mutation throws an error with a status of 401, this is going to be handled globally for you. So you don't have to deal with this case inside every mutation. Now, one of the coolest things you can do with React Query is to implement optimistic updates. Optimistic update just means that you show the user an updated state after making a mutation without having to wait for the backend. And this is especially useful if your backend server is asynchronous or if you're dealing with a physical machine that takes time to apply your changes. And there are actually two ways of implementing optimistic updates. The first one is in the UI. And if we go back to our contacts table example, we can have a custom hook, use contacts being deleted, and it's going to return a list of contacts ID that are currently in the process of being deleted. And then we can filter out the contacts and use these contacts to show the updated UI. And we can create this custom hook, use contacts being deleted, pretty easily. There's a use mutation state hook that we can use from React Query. And here we can filter them using a mutation key. And in this case, this is going to be delete contact. And of course, this mutation key should be the same one that is used inside the mutation. And then we can simply filter out these mutations. So we can check if the mutations are currently pending. And then we can grab the variables that are passed to the mutations. And this is going to be our contacts IDs. Now, this works pretty good, and it has the advantage that it's pretty easy to set up. But of course, it has the disadvantage that if you're using the query somewhere else in the UI, then you should also do the optimistic updates over there as well. Another approach would be to, instead of implementing it in the UI, you can do it on the cache level. So we're going to have a direct access to React Query's internal cache, change the data there, and that way it's going to reflect everywhere in our application. So if we go back to our use delete contact, we can pass in another parameter onMutate. First thing we can do is to cancel all the outgoing queries, so that way they don't overwrite our changes. And then we can grab the queries that we want. And in this case, this is going to be contacts list. Then we're going to apply our changes to this query. And here I'm just filtering out the contacts. And if there's a contact with the given ID, we're just getting rid of it over here. And then we can update the cache using query client.setQuery data. And as a last step, we're also going to return the previous contact pages. And this is going to be used in case we have an error. So if we have an error in our mutation, we want to reset the state over here so that way we don't break anything. And of course, it also does make sense to invalidate this contact data once that the mutation is done. Now, the last pattern I want to show you today is the solution to a problem I see in a lot of applications using React Query. And this one has to do with queries and especially how they load. Now, when you have a lot of queries in your application, this can lead to a lot of spinners and a lot of flickering that happens before the content is loaded. And for that, we can use suspense queries. These are really powerful because they just allow you to have a global loading state. So this is how your code will typically look like. You have a lot of loading states in every component. And what suspense queries allow you to do is to simply get rid of all these loading spinners inside each component and then use suspense query instead of use query. And one last thing to do here is to define a global loading state. And for that, we can use suspense from React. And in the fallback, you can simply define your application skeleton. So that was my practical React query patterns. If you work with other people on a project and you're using React Query, then please make sure to share this video with them. I'm sure they're going to get a lot of value out of it. By the way, I am currently offering consultancy services. So if your team needs support creating a modern, beautiful, and scalable front-end application, then you can reach out to me. I'm going to put my contact information in the description. All the code that you've seen in this video is going to be in the description below. Thanks again for watching and see you in the next video.